Hello all, in this video we are going to cover the topic that is the conversion from Mealy machine to Mealy machine. First of all, it should be clear to you what is Mealy machine and what is Mealy machine. Just as an overview, in the Mealy machine with each and every state there is an output associated. That means if you are having without any input string, you will get some output, because with the initial string, with the initial state, the output is also associated. At the same time, with the Mealy, with each and every input symbol, the output is associated with you. So here in this example, we are going to cover conversion from Mealy to Mealy. That means first of all, in the input, we are given the transition table for the Mealy machine, or we are given the machine, that is the Mealy machine. Here in this example, we are given a table for the Mealy machine. Just take an example. 3 columns will be there. First, the number of states, and then the next state where it is reachable, and the associated output. Just take an example. P, here arrows indicated. What is the arrow indication? It will be always arrow, that means the starting state. If there is a star, wherever it is indicated, that is the ending of the string, that is the final state. Okay, so here P is the starting state. So from the P, what this table is indicated, from the P, if next input symbol is 0, you will go to state S, and with the 1 and goes reachability is Q, but with the state P, the output associated with P. Just take an example. If we will draw the same, if I am in state P, the output associated with the P, the output associated is 0. That means with the P, the output associated 0. If the input symbol is 0, we will go to state S. That means if the input symbol is 0, we will go to state S. If we are in P, input symbol is 1, we will go to state Q. If we are in P, input symbol is 1, we will go to state Q. Here initially we are not indicating the output what is associated with that, but we have to, because with the S, what is the output associated? 0. That means the state will be as 0, and with the Q, the output associated is 1, that means 1. So either you are given as an input this type of Mealy machine, or the table is given, whatever is given to you. So very first is, if the machine is given to you, you have to make a table. It is necessary, because ultimately when we are doing the conversion, the table should be with you, because from the table you are going to avoid the transitions that you have to do while converting to the Mealy machine. So the very first step while we are doing the conversion from Mealy to Mealy, the very first step is construction of the trivial Mealy machine. Trivial, that means it can be minimized, it cannot be minimized. So first of all, just an example, what you have to do, just take the first state, that is the state P. What is the output associated with that state? Here in our example, it is 0. That means moving the output associated with P, which is 0. Here with the P, the output associated 0 to the transitions entering into the state P. That means wherever in the next state P will be there, we will just shift 0 with the P, and here we will use the null, that is the dash symbol. So the next our table will be dash, and wherever in our next state P is used, we will use simultaneously the output with the state that is 0. That means here the only one time P is used, so with the P we will associate the output, that is the 0. One by one we will do the same step for all the state. First we have do this for the P, now we will do it for the next state, that is for the Q. With the Q, the output associated is 1. That means the second sub part of step 1 is for the state Q, and output associated is 1. That means in this table, wherever the Q is used, with the Q we have to associate the output as well. The output is 1. That means wherever the Q is used, here and here we will associate it 1, and with the output we will make it as a null. Okay. That means the second sub part of the step 1, first we have moved the output associated with the first state, that is was the P. Second, we have associated the output associated with the second state, that is the Q. So wherever Q is used, we will be used Q with the 1. The third is we will use it wherever the R is used, we will associate it with the 0. So we will see in the next, that is wherever the R is used, here and here, so we will use 0, and here we will use as a null. The fourth is we will use S with the place 0. So here, here and here S is used, we will use 0. So with the S, 0, 0 and 0. So this is the final output for the step 1 only. It is the trivial Mealy machine. That means it can be minimized, it cannot be minimized according to the reachability of the state. Now the second step is actually we have to do the minimization of the Mealy machine. The output of step 1 is this table. That means this is the table for the Mealy machine. If you have observed, while we are having the Mealy machine, we are having the 3 parts. Because in the Mealy machine, with each and every state there is an output associated, but while we are moving to the Mealy machine, with each and every state there is no output associated. Why? The reason is that in the Mealy machine, with each and every state, with the input there is an output associated. What this step is indicating, if we are in state P, 0 input symbol is there, we will go to state S with output 0. If we are in state P, 1 input symbol is there, we will move on to Q with output 1. Okay, so just we will summarize this table again and we will draw the Mealy machine. How we will draw? If we are in P, input symbol is 0. If we are in P, input symbol is 0. This is 0. Output we will reach to a state S, that means here we will reach with output at that time 0. That means by slash, this is the output, that is 0. If we are in state P, 1 input symbol is there, we will go to state Q. If we are in P, 1 input symbol is there, we will go to state Q. At that time the output you will get as 1. That means the output we will associate it as the 1. If you are in state Q, 0 input symbol is there, you will go to state Q itself with the output 1. You will go to state Q itself with the output 1. That means if you are in Q, 1 input symbol is there, you will be if you are in Q, 0 input symbol is there, that means this transition you will be in Q with output 1. That means if you are in Q, 0 input symbol is there, loop will be provided because the self reachable state is there. That means you will be in Q with the output 1. If you are in Q, input symbol is 1, you will be in R with the output 0. So if we are in Q, input symbol is 1, you will be in state R with the output 0, and like on we will generate. So this is the final Mealy machine for the given Mealy machine. Now this is the minimized Mealy machine, but it may possible that in some of the example this is not the finalized. That means try for the minimization. If it is, then use the minimize. Here it is already minimized, that means no further minimization is possible. How you have to check for the minimization? Just take the same example that we have used for the further machines. Here we are having P, Q, R, S. So just make an set here in this example, P, Q, R and S. Okay, so check the reachability like the example minimization of the Mealy machine that we have already done. From where to where the reachability is there? Is there any division of the states that is going to the other transitions? That means it may possible that S0 and S1 will be there. For the same state, the number of states will be there. At that time you have to do the minimization. Hope you are clear now. Do the examples. If you have any doubt, then you can ask. Thank you for watching the video.